So again, these lectures, we're going to discuss about matrices. This time we are going to section 3.2. How do we multiply matrices? So multiplication of matrices. Now there's one special rule in order to multiply two matrices together. The first matrix column must be the same size as the second matrix row. Multiplication, you do two matrices at a time. You multiply two matrices at a time. So our main objective again here is to multiply two matrices. So example is given here. And here we say many computations that occur in business and also manufacturing operations can be expressed and analyzed by using matrix multiplication, because most of this data will be organized in a tabular form. As we said earlier, matrices is more or less like a table, organizing data like a table, rows and columns. So for example, suppose one store of an electronic retailer has 30 plasma TVs, also 20 LCD TVs, and 10 home theater systems in its inventory. Now the value of each plasma TV is $800. For each LCD is $750, and that of each home theater system is $500. Then we can do this calculation without using matrix. I was okay, I have what? 30 plasma TV, and one is $800. So 30 times 800 will give me the total value for the plasma TV. We have 20 LCD, so it's to be 20 times 750. We have 10 home theater, the price is 500, so 10 times 500. If we do this calculation, we get $44,000. But we can arrange this calculation in a matrix form also. And that's what we are doing here now. Remember, we have to arrange the matrix based on the units. Let's make sure the unit of measurement is important. So the first matrix, 800, 750, 500, those are again, the prices. So you see all the prices are together. Then 30, 20, 10, those are the quantities. All the quantities are together. So it's the same thing I will do. Now, as we said earlier, we are assuming this is matrix A, the prices, and then matrix B is the quantity of each item. First thing we check, is the number of columns the same as number of rows? Yes. The first matrix number of columns is 3. The second matrix, the number of rows is 3 also. So we can do multiplication. Now, if you say the first row of the first matrix is 3, no, it's 1. Then the second matrix, the row will be what? 3. We don't use rows. Sometimes we have students, because the size of a matrix is always the row by columns. And when they are checking the size also, they will say the first matrix row is equal to the second matrix column. That's wrong. So if I use that condition here, then this matrix, we cannot solve it, because the number of rows for the first matrix is 1. The number of rows for the second matrix is 3. So we can't solve it. So again, the number of columns is 3 for the first matrix, and the number of rows for the second matrix is also 3. So this will work. Now, what we do is that we take the first term and then the first term of the second matrix. They are all in the same position. We multiply 8 together. So 800 times 30 plus the second term multiplied by the second term of the second matrix. So 750 times 20. Plus the third term, 50 times 10. Then we add all together. Now, when we add all this together, we get the same amount, 44,000. So this useful way of operating with a row matrix and a column matrix, which we call the product AB. Okay. So this means, again, anytime we are doing multiplication of two matrices, the first matrix column should be equal to the second matrix row. So we have A1 to AN. You can see the second matrix is B1 to BN. So the size is N, the same size. Okay, if that's the case, then A1 times B1 plus A2 times B2 plus A3 times B3 all the way to plus AN times BN. The positions is very important. Now let's move to a more bigger matrix. This time our matrix size is 3 by 2 instead of again 1 by 3 or 3 by 1, etc. So the previous one we have 1 by 3 and 3 by 1. So first matrix column is the same as second matrix row. So this is store 1. This time the reason why we have 2 columns, one column for store 1, second column is for store 2. So both stores have different quantities. But the price, if the values of the items is the same, 8, 750, and 500. And we have already seen this calculation for the first one will give us 44,000 store 1. Store 2 value may be different. So that's what we're going to do. We get 53,250. So what we did, we multiply again the price. The price is the same for both stores. So I multiply 800 times 40, 750 times 25, 500 times 5. And this will work. Why? Let's go back to the rule. Even we had a second column, but we can look at the rule. The rules stay the same. We say the first matrix column should be the same as what the second matrix row. So it doesn't matter how many columns we have in the second matrix. We don't check that. We only check the number of rows. So if we had 1 row more to the second matrix, then we cannot do any multiplication because the rule will not work. The rule said the first matrix columns should be equal to the second matrix row. So this works. But this time our answer will be 2 values because we have 2 columns. We take 800 multiplied by 30 plus 750 multiplied by 20 plus 500 multiplied by 10. Then we add all the value. That's 1 value. We get 44,000. Then we take 800 multiplied by 40 plus 750 multiplied by 25 plus 500 multiplied by 5. We add all together. We get 53,250. And that will be our submission. So the total price for first store is 44,000. Second store is 53,250. So here we say the matrix we have represented so far as AC is called the product of a row matrix A and the 3 by 2 matrix C. The second matrix have 2 columns, so it's 3 by 2. Again, when you are talking about the size of matrix, the number of rows come first before the column. Now, since the first matrix, the number of column is 3, and the second matrix also the number of rows is 3, we can do multiplication. Now, what if we have 2 matrices and their size is more than, each one have more than 1 row or 1 column, more than that? Remember last time we said if a matrix have only 1 row or 1 column, it's called a vector matrix. So we are going to do a multiplication of 2 matrices and they are not vector. So here, for example, I'll check, I have matrix A and B. So what I'll do is I'll check the number of columns here is 1, 2, up to N. And the number of rows too is B1, B2, up to N. So they have the same, the first matrix, the same number of columns is equal to the second matrix, the number of rows. So if that's the case, we can do our calculation. I will take A11 times B11 plus A23 times B12 plus, so you keep going until you reach the end. And again, we're going to do an example. So when we finish, same as we did previously, let's go back here one more time. You can see that here, we take 800 multiplied by 40 plus 750 multiplied by 25 plus 500 multiplied by 5. So you take 1 row and 1 column. And that's what we are doing here. I take one row, A11, A12 up to A1, and multiply by B11, B21, Bn1. The second column will be B12, B22, B2. Again, I will use the first column, the first row in the first matrix, and second column. That will give me the position of C12. So let's see an example. So here we have example, and this is the data we generate from 3 different items, steel, wood, and plastic. And these are the different divisions. And the second, we were able to generate the Western and Coastal. There's 2 supply companies considered, Western and Coastal. And this is the amount of items they generate. Now they say we should use matrix multiplication to decide which supplier should be chosen to supply A, the Clarion division, and B, the Brooks division. So here we have a matrix. Let's put the values together. You can see the steel, wood, plastic, 30, 20, 30, 80, Clarion, 22, 25, 15, Brooks. Then the divisions, we have Western and Coastal, and also the number of steel, wood, and then the bricks for each division. So now we have to do the multiplication of the 2 to see which one to take. So now we can see here, the first matrix A, we have 3 columns. Good. The second matrix B, we also have 3 rows. Okay, then we can do the multiplication. It's okay. Since the number of rows of the first matrix, the number of columns of the first matrix is equal to the number of rows of the second matrix. You can do the calculation. So the first thing we're going to do, we take 20 multiplied by 300 plus 30 multiplied by 100 plus 8 multiplied by 145. Then we add all together. That will give us the element in the first row, first column, because we are using first row, first column. Now I'll take 20 multiplied by 290 plus 30 multiplied by 90 plus 8 multiplied by 180. The answer I will get, it will be the first row, second column, because I use the first row values and second column. So the answer will be first row, second column. Then I'll keep going, take the second row and first column, 22 multiplied by 300 plus 25 multiplied by 100 plus 15 multiplied by 145. And that will be my second row, first column. Then 22 multiplied by 290 plus 25 multiplied by 90 plus 15 multiplied by 180. That will give me the answer for what? Second row, second column. So that means when we finish, our answer will be 2. So this is what they did everything. So to be 2 by 3. We have 2 rows and 3 columns. That's the values here. So that'll be the final. Oh, sorry, to be 2 rows, 2 columns. Yeah, 2 by 2. So that will be our solution for the matrix. So here we say the price for the Clarion division for surprise from Western is in the first row. And we can see the differences in the prices. First column, it's 10,160. It's better than Costa is 99.40. So the best price, of course, will be 99.40. We are going to buy, so we need lesser price. If I'm selling, then the best price will be 10,160 because I want more profit. So let's try this example. The price for the Brooks division for supply from Western, again, is in the second row, first column, and also is this amount. The price for books for supply from Costa is in the second row, second column, and this is the price. Now, that's the best price for Brooks is from the Western, and that is true. Now, let's try the next section, which is multiplication of matrices using identity matrix. So we say an n by n. Now, identity matrix, the first thing is that it have to be a square matrix, so that when 1, 1 is go across, it can go from beginning to end. If the rows and columns are not the same, you may not get an even diagonal values are the same. So this is identity matrix. The values in the diagonal section is 1, 1, 1, the rest are 0, 0. So here we say an n by n squared matrix where n is any natural number that has ones down is diagonal and 0 everywhere else is called the identity matrix. And here we have 3 by 3 identity matrix. We are going to represent a matrix as I, identity matrix. So this is called an identity matrix. And the size is 3 by 3. So we should know A will be the A matrix, then AI, then IA or A. You can use any notation there. So let's give an example here. Write a 2 by 2 identity matrix. Well, that means I'll get 1, 1, then 0 at the rest. So we have 1 diagonal going down, then 0, 0. Now, the next thing we're going to do is that we want to show that if I have a matrix A, which is 4 minus 7, 13, and 2, we should show that if I multiply matrix A with identity matrix, or I multiply identity matrix with A, or the identity matrix itself, the answers all will be the same. So we have to check AI. We already know identity matrix is 1, 0, 0, 1 here. So we multiply 1, 0, 0, 1 by 4 minus 7, 13, and 2, and see if we get A. So again, if you have a question, you can interrupt me at any time. We have only 2 students now. Again, I'm going to post this in the recording. I'm recording it, I'll post it in the class. So this is what we do first. We want to find AI. So we have A times I. I is the identity matrix. And we know this multiplication already. So we multiply 4 by 1 plus 4, 4 by 0, negative 7 by 0. That's what we have here, 4. And negative 7 by 0 will be 0. Then the second, well, let's do first row, the first row, second column, 4 by 0 and negative 7 by 1. So that will give me negative 7 right here. Then 13 by 1 plus 2 by 0, that will give me 0. And the last will be the second row, second column, 13 by 0, and then 2 by 1. And that will give me 2 here. So if we do this, our answer will be 4, 13, negative 7, and 2. Yeah, the answer is the same. So AI is the same as A. Now let's see the other one, IA. So now I is in the front. So we multiply the first row with the first column. And 1 times 1 is, 1 times 4 is 4. 0 times 13 is 0. So we get only 4. Then 0 times 4 is 0. 1 times 1. So we get 13. That's correct. Then we do 1 times negative 7 is negative 7. 0 times 2 is 0. Then 0 times negative 7 and 1 times 2 is 2. So they're also the same. 4, 13, negative 7, and 2. So which shows that AI equal to IA and is equal to A is correct. So that will be the conclusion of, again, section 3-2. Now I'm going to wait for a few seconds if you have a question before we stop the recording. Okay, so if no question, then again, I stop the recording and thank you for your time.